Welcome to section 3.3. Now in 3.3 we're going to focus on aquatic biomes. So we're going to talk about freshwater biomes a little bit, we're going to talk about marine biomes a little bit, and then we're going to talk about some of these borderline, these transitional biomes between land and water. Now once again, my goal is not to make you memorize everything about them. It's more to understand the significant events that happen, kind of how they work, more than just all of the words. So the pieces I do talk about you should know, but you'll see there's a bunch of stuff in the book that we're not going to get into. I'm not going to cover all of the terminology. So for freshwater biomes, what I want to make sure you understand that's critical is when you look at things like lakes, they're not as deep, they're not as big as the ocean, but they still have some significant things that happen. And ultimately what this comes down to is you have oxygen that's hanging out in the atmosphere, and that oxygen will then diffuse into the water. You also have sunlight from the beautiful sun there that's going to be shining down into the water in that top layer. So if you're in a lake, the top layer of the lake gets most of the oxygen and it gets most of the sunlight, which means most of the photosynthesis is going to happen in this kind of top layer. Now at the bottom you're going to get things dying, they're going to sink, they're going to start decomposing, and so they'll release nutrients. So in this bottom part is where we're going to find our nutrients in highest amounts. So for a lake, this can be a big deal because you have lots of plants, lots of organisms that need those nutrients, but they're deeper down. And many of those also, those algae, the seaweed, will also need sunlight so that they can get energy so they can actually build food. Not to mention you have things like fish that need oxygen in high amounts, so they might have to stay out of those deeper levels where there's not as much oxygen available. Now, this is not always a big deal, but it can be a huge deal in the summer and the winter because we get what's called stratification. We get layers. And so you'll see in the winter you get these layers with the ice, then you have a little bit warmer than colder water that kind of layer together here. And in the summer, which is where it's the biggest deal, you're going to get the warm water on top, and that's going to kind of circulate, and then below it you have this colder, this nutrient-rich but low oxygen water that's at the bottom. And so because of this, a lot of organisms can't get everything that they need. And so you want to make sure you can churn all of that. Now this happens naturally in spring and fall when the temperature at the top here changes. It allows for this mixing because the water that's on the top starts to cool, so it sinks, so we get this turnover, they call it. You can get the same thing when the ice melts, where you've got warmer water below that kind of starts to churn up, which allows us to get this kind of churning that occurs, which makes the nutrients get pushed up and the oxygen get pushed down. So everybody's happy. But when you're in the middle of a season, like winter or summer, this can kind of fall apart. And so that's why many lakes and like small ponds people put in, you'll notice that they've got fountains or they've got like these bubbling areas, and the whole purpose of what they're doing is trying to create this broader turnover. And so they'll put stuff at the bottom, or they'll pull water from the bottom with a fountain so it makes the water circulate. So it allows oxygen to get down and it allows nutrients to get up so it's balanced. That's what makes it healthy. Otherwise, you can get the same problem where there's so much decomposing stuff on the bottom and not oxygen. That can kill fish. That can cause you can get algal blooms up on the top because you've got all these algae with the sunlight and there's nothing controlling them. So it's a bad thing to have too much stratification. So for lakes, turnover is a great thing. This is one of those things you want to be careful of if you ever have a pond or a lake. Now, transitional ecosystems are kind of cool because they're on the border. So these are things like the Everglades, these are things like Delta, these are wetlands as they're oftentimes called, where we're going to be mixing land and water. So these are areas that might be covered mostly by water, like most of the time, but it's typically shallow water. You still get lots of plant life. This is more like swamp type area. Some of them can even be around the ocean, at which point you get a mixing of the salt water and the fresh water, so you get brackish water. That just means it's like half salty. It's not fully salt water, it's not fully fresh water, it's kind of an in-between. But these areas, because they do have a pretty large availability of water, these are also some of the most biodiverse and prolific areas. If you go to areas like wetlands, while they might not have quite as many species as a tropical rainforest, they have a lot, because there's a plentiful supply of water. In many cases, these are in fairly temperate to tropical areas, so the temperatures are pretty good, at least for part of a year, and you can have a great mixing of food webs, both aquatic, if I can right here, and terrestrial, land. where there's lots of organisms that will feed upon fish. There's fish eating the insects that are basically from land. So it's kind of wonderful we get these two worlds meeting and interacting. And so this is great. So if you're a bear or something, you can wade out and you can eat the salmon. It's a wonderful idea, and it helps increase that biodiversity because there's so many more options for food. There's so many more options to kind of diversify the food web itself. Now, marine biomes is what we're going to kind of finish with. And this one, I'm going to go through a few terms, but I'm going to try to keep it fairly simple. So you're not going to have to memorize all these terms you see here. What I'll start with is you have the region that's on the far edge. So this is the part that's going to be considered the tidal zone. All right, and the tidal zone, the whole point here is these are the regions where it's wet part of the time and it's dry part of the time because you have high tide and low tide. So this area still has quite a bit of biodiversity because you're yet again talking about this kind of mix between water and land, because it's water part of the day, it's land part of the day. So a lot of organisms will be there at least for part of the day, either because they're trying to clean up organisms from the beach that have washed ashore during the high tide. You've got crabs and things like that will come through and just feed in general, and they might hide or they might just go around also scavenging during the daytime or whenever low tide is. And so that'll be the tidal zone. And then after that, we've got this zone where it's pretty close to the surface. It's always wet, but it's still near the surface to where the ground, the actual bottom of the ocean, still gets light, plenty of sunlight, so photosynthesis can occur. So this is one of the most diverse areas as well that we see, and that's primarily because it has sunlight, it's got the nutrients from the bottom, the silt that's there, and it has light, so you can get large seaweeds and kelp and algae growing there. So that helps you get a really strong foundation of autotrophs to build up the rest of the food web. So the tidal zone's pretty diverse. When you get into this shallow area, that's the shallow shoreline, if you will, but that's always submerged, it's going to be diverse. And then as we start to move out to get into the deeper ocean, we're going to talk about photic, which just means the area at the top that gets light, so it has enough light to do photosynthesis. So this is still going to have a fairly large amount of algae, even though it's normally smaller algae. And so this will still be pretty diverse. It's not as diverse as some of the others because it doesn't have the soil to provide nutrients, but it still has photosynthesis, so it's not bad. And so this will be the upper layer of the ocean. Pretty much the whole ocean away from land, the upper layer. And then as we go down, we start to get darker and colder. So we get into the aphotic zone, where there still might be some light, but it's not enough for photosynthesis. So maybe you can see okay, although as you get deeper and deeper, vision's going to get worse and worse, but you're not going to have a very strong food web in the sense that the autotrophs are not really going to be there. Unless you get lucky and there's some chemoautotrophs, some chemosynthetic guys, you're going to have to just kind of wait for dead stuff to fall down to feed upon. And so that means that down here, it's a lot less diverse. There's not as many organisms because it just can't support them. There's not the energy for it because they have to just kind of feed upon whatever happens to fall their way. They don't have that autotroph base to help them have all kinds of organisms. And then you get deeper and deeper and deeper, and you might eventually see what's called the Abyssal Zone, which is just where it's pretty much pitch black, really cold, really deep. I mean, we're talking in many cases miles deep. And it's going to be crazy high pressures, and it's going to be very sporadic in terms of food. You might get a big fish that dies and falls down and you can feast, but then you might be waiting long distances, or long times, I should say. You might be waiting long times before the next meal falls down. So it's very feast and famine. And then benthic is just what refers to the seafloor. So benthic is just going to be anybody who's living on the seafloor. When I talk about it, I'll usually be referring to benthic a bit deeper. When we're talking about tidal zone, I mean, I don't usually say benthic because that's partly on land half the time. When I talk about the really shallow seas, I'm not normally going to say benthic because it's still getting sunlight. But especially when we talk about this deep sea floor, that's going to be benthic. And so once again, it's not going to be the most diverse just because its food is going to be feast or famine. It's going to be when something falls down that it can ultimately use for food. But it is kind of cool because we see a lot of organisms we don't necessarily see elsewhere, like some of the crabs. We'll see lots of types of worms. We see some cool stuff that's not just fish or squid or some of the usual things that you expect when you're looking in the ocean.